In this video, I'll describe the procedures necessary to install this power-saving device onto this precip sensor. Let's first start with the tools that we'll need to complete the job. We'll need silicone caulking, some electrician's tape and or vulcanizing tape, some wire strippers, heat shrink, a soldering iron and solder, some insulated connectors, wire cutters, a blade screwdriver, and a utility knife. Alright, we'll start the process by installing these insulated connectors into the sensor housing. And we'll start by removing on the underside of the housing these 5 screws. Once the 5 screws have been loosened from the underside of the cover, we can simply lift off the top portion of the cover. Note there's an electrical connector here that powers the sensor heaters, and also note the orientation before removing, so when reinstalled it does not get reversed. On the heater plate, you'll notice that there are 2 transistors that are used to heat the plate. One of the wires will go from the emitter of one transistor to the collector of the other. That's the wire that we want to cut. With the wire cut, we can go ahead and install these male and female connectors. We'll have 1 pair of each. When doing so, it is a good idea to use 1 male and 1 female connector on the inside of the sensor here. That way, if we ever want to revert back, we can just simply plug one into the other. And then the other male and female connector will be attached to the sensor controller. I feel it's best to solder these in rather than just using the crimp-on part. However, soldering this insulated connector can be a little challenging because there's no real way to access any part of the metal for soldering. So what we'll do is cut off this little lip here, and that'll allow us to have access to the metal part where we can actually solder in. Okay, to better illustrate this, I thought I'd show you a side-by-side comparison of what I'm talking about. Here's the uncut connector and then the cut connector, and I just used a utility knife and rotated the connector on it and it cut. And here, now you can see that we have good access to some metal here that we can actually solder to. I feel the easiest way to solder this insulated connector is to first of all tin the ends of the stripped wire here, and then on the connector itself, go ahead and preload it with some solder. That way when you're ready to make the connection, you can just heat the connector up and then push the wire in. The female connector can just be crimped and then expose a little bit of the wire and then solder that. This is what it looks like when it's all soldered together. This way, if we ever want to revert back to normal, we can just plug one connector into the other. We will use this spare opening here on the bottom side of the sensor to feed our wires from the controller into that housing. However, we want to first feed the wire through before we solder on the connectors. If we put the connectors on first, they will not fit through that opening. I have found the easiest way to feed the wire through is to first of all remove the plug on the bottom side of the sensor and then take the plug apart. There is a rubber plug inside this that needs to be removed. Once that's removed, this can be reassembled and then we can feed our wire through. Now I have reinserted the grip sleeve into the plug and then reinserted the plug into the housing. Now the next step would be to install or mount the control box onto the arm. That way when we wire this up, we won't have to worry about straining any of the connectors. Prior to installing the control box onto the arm, it's a good idea to wrap the arm with some tape where the clamps will bite down onto the arm. That will provide a little bit more friction and prevent the box from rotating on the arm. To install the control box onto the arm, first remove the brackets from the back side of the control box. Once removed, you can swivel the bracket or the clamp here 90 degrees from the bracket. And then the bracket and the clamp can just be put onto the arm as such and then just rotate back 90 degrees. Once the brackets are on, just remount the control box using the wing nuts and the screws. Once the control box wires have been routed through the bottom side of the sensor and come up back into the sensor, we can just plug those back in along with the sensor heater plug and then reattach. When reinstalling the sensor cover, be sure that the rubber gasket is well seated into its channels for a watertight fit. The next step is to install the moisture sensor. This will be installed on top of the precip sensor. Since the sensor heaters are just below this surface here, when they come on, they will also heat the moisture sensor and help evaporate any moisture on that sensor. Once that is dry, the control box will then chop power once again to the sensor heater, then saving power. So to install this plate, just use some silicone caulking, place it on the back side of the plate, and then just set on the center portion here of this sensor. Once it's dried, we can then attach the wires for the sensor. Once the silicone caulking has cured on the bottom side of the moisture sensor, go ahead and connect the sensor and then apply some more silicone caulking around the connectors to prevent any kind of corrosion that may occur later. Okay, now that we have the control box mounted and set up here, it's time to test the unit to see if it works the way that it's supposed to. This sensor here is a 24-volt system. It can run on either AC or DC. So what I've hooked up here is I'm using a 12-volt battery that goes to this step-up converter, which converts the 12-volt DC to a 24-volt DC, and then that goes in to the end of the arm here that powers the sensor. When you hook this up, the middle plug here should be the positive, and the non-colored one, you can see there's two blacks and one yellow. The other non-colored one on the end would be the negative power. The colored one is for the relay. When the sensor detects precipitation, it'll send a voltage out through that and over to the collector. So anyway, we have it set up here. I also, on the output side of the 24 volts, I have a power analyzer so I can see how much power is being used by the sensor. So right now, the control box is set in the off position, and you can see here that we are only drawing, looks like 0.01 amps, which is the amount of current that's necessary just to run the sensor device. So if we move it to bypass, that should allow the heater and the sensor to come on. So when we turn this to bypass, we should see the amperage go up on the power analyzer. So I'll go ahead and turn that, and then you can see it went from 0.01 all the way up to right around 1 amp, and it will come down a little bit as the the heater plate warms up. So anyway, the bypass works. Now we want to test the moisture sensor and make sure that it works. So we'll move the switch down to the on position, and then the red LED comes on the control box, and that indicates that this box has power and the device is on. The green light indicates that it's in standby mode, which means it has opened the circuit to the sensor heater in this box here. So now the way it's supposed to work is when moisture accumulates on this moisture sensor, it should open a relay and then allow power to flow in this box here to the heater. So I'll simulate some moisture by wetting my finger and then just placing it on the sensor here. And when I do that, the green light in the standby mode there should go out. So I'll go ahead and touch that, and you can see it went out. And then you can also see that our amps went up, which means that the heater is currently on. This heater will be on at any temperature below 30 degrees C, and it's progressive all the way down to 0 degrees C. So if you're testing this in a real warm environment, obviously the heater won't be on and you won't see that additional draw. So when you're testing, make sure that you're below 30 degrees C. Okay, and then the moisture just dried off there, and you can see our standby light is back on. Another thing to note, or that you should be aware of, when testing this sensor, the sensitivity of this moisture sensor here can be changed. I have just left it on the default setting, which actually seems to be pretty sensitive. You can actually get the system to activate just by breathing on it. And the need for this switch after testing, if the box proves itself, there's probably no need for this. It adds additional expense and more parts, and also provides another path for water to get into the box. So what I envision is, when that system proves itself, is building a control box like that without the switch. Again, it's much simpler and easier to build, and also it allows me to position the circuit board in such a position where we can just pop open this cap on the end here and adjust the set screw for the sensitivity of the moisture sensor. If you do not have access to a power analyzer like this, we can still test the unit either by using a multimeter and hooking it in series with the circuit and then put it onto the amp setting, or you can also just wait a bit, about a minute or so after the heat element is on. You'll be able to put your hand on the sensor here and you'll feel the heat. If you have any questions, feel free to email me at mattj@usgs.gov or give me a call at 503-251-3242.